Hello everyone, this is Mahmoud Matouk and this is an overview of OpenShift Enterprise version 3.2 product and the platform as a service in general. So our agenda is to go over an overview of platform as a service and OpenShift Enterprise architecture and discussion. We will discuss the core technologies associated with this product and with platform as a service in general. This will include Dockers, Kubernetes, and containers. And we will have a discussion over the environment, architecture of OpenShift, and we will have few demos on the web console and project application management. We will have a demo on creating builds and configuring webhooks to trigger automatic builds when we push changes and commit our changes to our Git server. And we will test the scaling configurations and scaling functionality of our application. So platform as a service is a category of cloud computing services compared to the infrastructure as a service, where you are handed over a virtual machine and you have full control over what is running on these virtual machines. You are responsible for maintaining your environment, clustering it, maintaining the scalability of your applications and the high availability of your application, and so on. It's a great effort to maintain an infrastructure as a service. However, with this comes the power that you have full access to your host environment, you have access to your machines, you can install whatever packages needed for your application, and you can install whatever software needed to run these applications. In a platform as a service, you have access to a platform where you can deploy your application. You don't have access to a physical machine, and you don't have access to any resources provisioned as part of making your application up and running. You just have a console. You can connect to this console through web console or through command line, or through some plugins and tools you can attach to your development IDE. And once you develop your application, you can push it to this platform, and it is the responsibility of the platform provider to provision needed resources, deploy your application, and make it up and running, and hand you the URL to your application. It's also the responsibility of the platform to monitor the traffic to your application. So if you have spikes or you have unexpected increase in your traffic, it starts provisioning more resources to serve this traffic, and once you back to normal, it will terminate the provisioned resources. So it's really very good from scaling and high availability perspectives, and it also very efficient from costing perspective, because you pay only for resources that you use, and you pay only for the traffic you get to your server. If you don't get traffic, you don't pay much. With this comes so many restrictions. You don't have access to a host machine, you don't have access to the running server, you don't have access to packages or components other than what you can package with your application. So if you have increased need to deploy some additional libraries to your server or to your host machine, or you need access to file system and so on, you cannot use platform as a service with these restrictions. So platform as a service is a great simplification to the development process, but with these restrictions on what you can do on the host machine. OpenShift Enterprise, or OpenShift in general, is based on running applications in Dockers and containers. In this container, you can package your software, the developed software, your application, together with environment variables or environment and runtime environment, and any other packages and libraries needed for your application to be running healthy. And then you can develop all of this in a Docker image, and you can host this Docker image on a Docker Hub, which is like the source control for Docker images. And then you can download this Docker image anywhere and run it, and your application expected to be running the same way you have developed it. So this is a solution to many problems. First, we used to have problems that something is running on a specific environment, and when you move it to another environment, it's not behaving the same way because of any difference in the operating system or the host machine or the configuration on this server and so on. So Docker is a solution for this. Whatever you have developed in your machine is expected to perform and run the same way wherever you run it on any other environment. The second problem is that if you want to scale up your application, in real world, you have to have additional instances of your server running. So if you want to scale an application that's hosted on WebSphere, you need additional WebSphere servers to be running to scale up this application or scale it down. You need to terminate these applications, or you need to terminate these servers, which is in real scenarios is not very elastic. You cannot increase it or you decrease it. You have to plan it from the beginning So you plan your cluster to have like 3 or 4 instances. To increase this or decrease this, it's a huge infrastructure and deployment process. In Docker, as everything is running in a container and you can grab this container and run it anywhere, you can have an elastic environment. You can have an environment that spans 100 instances of your application when traffic requires this number of instances, and scale between these applications and load balance between them and provide high availability through other software deployed to your cluster. And when traffic backs to normal, it can terminate the instances that are no longer needed from your application. So it's really an elastic environment. It can scale up and down based on the traffic and the need, and it can make the best use of resources together with platform as a service, as you already pay for only what you use from resources perspective. So when you have spikes in your traffic, the platform will start more instances of your application and you will start paying more. But when you are back to normal traffic or less than normal, the platform will start terminating instances that are no longer needed, so you don't have to pay extra money for these. So it's really an elastic environment, and having applications running in Dockers and containers is a great addition to the extensibility and the elasticity of this environment. So this is one of the famous diagrams that we usually see when we read about Dockers and containers, and this is taken from the Dockers website. It compares Dockers to virtual machines because they are very similar in the concept. However, they are very different from architecture perspective. In the concept, when you develop a virtual machine and you bought many applications on them and you hand this virtual machine to your customers or your team or your developers or somewhere else, it's expected to run the same way that you have developed it, regardless of the host operating system. So this is exactly the same with containers or Docker images. However, Docker images don't have a guest operating system. They just have the running application and the binaries and runtime environment needed for this application to run and function properly. On virtual machines, you need a hypervisor which actually virtualizes the infrastructure and provides a piece of this infrastructure to each virtual machine to run on. On the Docker and container side, you have a Docker engine which provides this functionality in terms of dividing the hardware or dividing the resources you have into pieces and give your Docker instance or Docker node the needed resources from memory and CPU perspective to run and function properly. So when you are adopting the concept of Dockers and running your application in containers, you need something to monitor and orchestrate and manage this cluster of containers. You can have 100 instances of your application running at a single time. This is Kubernetes. This is a cluster manager or a scheduler or an orchestrator that can manage and moderate your cluster. It is responsible for maintaining the containers up and running. It is responsible for scaling up and down by spinning more containers or terminating containers that are no longer needed. And in a typical Kubernetes environment, you have a master node which has a scheduler together with other APIs needed to monitor this cluster, grabbing metrics of your nodes, the traffic load, and it also has a scheduler who is responsible for starting more containers or terminating containers that are no longer needed. On the other side, you have nodes, which is the actual machines that are running your containers, and on these nodes, you have a component named kubelet. Kubelet is like the node agent, through which the Kubernetes master can connect to this node and get the information about running containers and give instructions to this node to start more containers or terminate containers that are no longer needed. So this is kind of a typical environment of Kubernetes. You have a Kubernetes master with a scheduler. You have other APIs, but the scheduler is actually the core of this engine, of this master node. But you have other APIs that are used to get the metrics of your cluster and moderate your cluster in different ways. And then you have the nodes, which is the actual nodes that are running your containers. And on each node, you have a kubelet, which is the node agent through which the master can connect and communicate with this node, giving instructions and collecting information. So for OpenShift, it's a platform that encapsulates the concepts of Dockers and Kubernetes as accurate as possible. And this is actually a diagram taken from the reference architecture of OpenShift Enterprise, and it's very similar in many ways to the environment we have seen here. Here you have Kubernetes master and you have the nodes, and here you also have a master and a cluster of nodes. On the master, you have the scheduler, which is the core of this master node, and you have other APIs used for moderating and monitoring this cluster. And on the nodes, you have running pods, and pod is actually a collection of containers running together. So it is still containers. You can think of pods as containers. So that's it about the general picture of platform as a service, Kubernetes and Dockers, and the architecture of OpenShift Enterprise. And in a typical OpenShift cluster, we have to do some planning because there are restrictions on this environment and installation, and there are restrictions on how many nodes and how many pods you can run on your environment. So you have to plan this at the beginning and know how many hosts and nodes expected in your environment and how much you need to scale your application. You also have to determine and have a vision of how many containers are expected to be running on each node and how big the applications that will be running in these containers, because you will be setting limits on these applications in terms of CPU usage and memory usage. So if you have a Java application that's running on JBoss, it's different than a Java application that's running on WebSphere. It's different than a PHP or a Node.js application that doesn't require any server. And then you have to decide on the high availability and the load balancing you want to be available in your cluster. Based on this, you can decide how many nodes and how many masters you need in your cluster. So in terms of system requirements for OpenShift Enterprise, it needs to run on Red Hat Linux 7.1 or more, or if you are running an atomic server, you need 7.2.4. For the master node, you need at least 2 virtual CPUs, and for each other node, you need at least 1 virtual CPU. For the master and the nodes, you need a minimum of 8 GB of memory, and you need at least 30 GB of storage on any master or node in this cluster. OpenShift Enterprise supports only 64-bit servers, and you have a maximum of 300 nodes per cluster, and you have a maximum of 110 pods per node. So this information, together with the planning information you know about your applications and how many pods or containers expected to be running in this environment, and so it will help you determine how big your infrastructure needs to be. The prerequisites for OpenShift environment to be running: you need a fully functional DNS in your environment, which can resolve internal hosts and external hosts as well. And this is typical for any environment that's using Dockers or containers. You cannot just depend on the hosts file, because hosts files are not passed over to containers when they run, and containers still need to resolve some of your hosts. Masters have to have implicit shell scripting access to the other nodes. And this is for the masters to be able to moderate these nodes and run containers and get the information about running containers and monitor the CPU and so on. Many of these commands are passed over through shell scripting to these nodes, so the master has to have implicit access to these nodes without authentication. There are multiple ports need to be open, and you can get back to the documentation for what ports need to be open between the masters and the nodes, and between the masters and the masters, and between the nodes and the nodes, and so on. And you need Docker to be installed and activated on all masters and nodes. So I have developed a demo environment for this, and I have done this on Amazon Web Services, and for this I have a virtual private cloud which hosts my environment, and in this virtual private cloud I have a public subnet which hosts 3 EC2 nodes, 1 master and 2 nodes. And this is an example of an infrastructure as a service actually. So I have taken 3 virtual machines from Amazon Cloud, and I have installed my software in them to provide a platform as a service to my developers. So in a typical architecture for an environment, I would keep my nodes in a private subnet, and I keep another public subnet having a bastion server I use to access my nodes and so on. But just for simplicity and for demonstration purposes, I kept this in a public cloud so I can connect to these master and nodes through my desktop. I also have configured an external DNS that resolves to my master node, and I have configured an internal DNS that can resolve my master and node for this environment to function. So we'll have a quick demo through which we'll go through the admin console of this environment. We will explore projects and applications, and we will see what are the functions available through this web console. We will discuss the builds and webhooks and how to deploy an application and how to have a webhook on this application. And we will check the manual application scaling, the scaling functionality of this environment, how to spin more containers and how to scale down when containers are no longer needed. So once I have my environment up and running, this is the console that a developer can access, and I will log in with one of the users I have configured on this environment. So this is a developer too. And once I log into this console, I don't have any projects running, and this is my landing page, and I get the option to start a new project. So we have projects and applications. I will start a new project here. I will name it demo PHP, or I just name it demo. Names have to be lowercase. Demo project. Once I create a project, I have the option to add application, and I will have the option to add applications as many as I want with this project. So think of a project as the namespace that groups your applications together. And here I have the options, the Docker images I can choose from to run my application on. So I have like PHP servers, I have Ruby servers, I have Perl, I have JBoss for Java applications, and I have Node.js. These all come out of the box, and you can get more of them, and they add more of them to the OpenShift products over the time. And more importantly, you have the option to develop your own builder or your own Docker image and register it with OpenShift, and it will be available to you here. So if you have applications that require WebSphere application server, you can have your own Docker image with application server, with WebSphere application server, and whatever other libraries needed for it, and you register it with the OpenShift platform, and it will be available for you to choose from here. So I will just go with a PHP application. I will choose version 5.6. With application, I'll just give it a name. So I'll name it demo PHP. And you need an access to a Git repository. So with an enterprise, you might have a local Git repository that you use for pushing and deploying your applications. This is a typical scenario, and you will have the URL to your local Git repository here. And this is just for demonstration purposes. I'm using one of my test applications on GitHub. So this is test PHP. You have more advanced configurations here. Some of them are related to scaling and resource limits applied to this project. I will not do any of these now because I do this from the command line. So here with the basic information, I will just create this project. And again, I need this name to be in lowercase. So now it's grabbing my application from GitHub, and it will build my application, and it will grab the image of the PHP, and it will deploy my application on top of this image and make it available and just give me the URL to this application up and running. So let's get back to the overview and wait for this magic to happen. And you see here that it already generated a route or a route to my application with the application name dash project name dot my subdomain. As you see here, the application is up and running now, and we have one pod or one container started for this application. If I open this URL, it will take me to my test application. I have here a test PHP, which is just printing the PHP information of my server, getting the versions, and so on. I didn't do anything to deploy this application. I didn't install an HTTP server or PHP on this running environment. I just choose the Docker image I want to deploy my application to, and I provide the URL to my resources, my source code. So the power of this engine is that it's scalable. You can scale up and scale down, so I can start 4 instances of my application, and this will happen very quickly, as you see here. And this means that I have 4 clustered instances of my application up and running. And imagine that this is double with any other technology. So you can have a big Java enterprise application running on JBoss or running on WebSphere application server, and you can just scale it up and down as easy as this. And when you do this, the load is automatically balanced between these servers, and the high availability is configured between these servers. So if one of these pods is down for any reason, the platform will start another instance for you, and the load will be balanced between the other 3 healthy containers. And you can definitely scale down when things are not needed, and you see how fast it happens here. Okay, so you also have access to many other functionalities on this console. You have access to the build, so you know what happened to your build and where it's coming from, and you can get into this build and you can change the location of your application. So if you decided to have another version of your application and you just want to build this version on the exact Docker image, you can just come here and change your application URL. You have other configurations here. You can control the build behavior of your application. You have environment access if you have any environment variables defined for you, and you can start a new build if you want. If you have done some changes to your application and you want to start a new build, you can do it from here. You have access to the pods, and you can also access the pod from here. So if you go inside, you see 2 pods. You can get inside this pod. You can see that you can have a terminal that gives you access to this running pod. You can also view the logs from here, and you can actually tail these logs if you have traffic or you have exceptions that are happening in your application, and so you can tail these logs and monitor them. You have access to the environment variables if you have any, and you have access to the events, which telling you the history of things that have been done on your application, pulling an image, creating a build, and so on. You have access to the routes to your application. If you want to create a new route, if you don't like this one, or you want to create a customized route, you can do this. So one nice functionality is configuring webhooks. So you can go to this build and you can go to the configurations and you see the webhook URL here. So I can just copy this URL and go to my application on GitHub, go to the settings, configure webhooks, and I can just edit this one. Okay. And I will paste the URL I copied from the platform, update webhook. And this creates a webhook for me. So if I go to my application and I edit any of these resources, it will trigger a build on the running application. So I'll just go to my index.php and I will update this to be version 3. And commit these changes, and if we get back to the console, you will see that it immediately triggered a build on my environment. Once this build is done, my changes will be up and running, and you see through the build process, it very quickly starts a new pod and it will terminate the other ones. And because I had 2 pods running, it started another 2 for me. And if I go to my application now, I will see that I have version 3. So for the developer, having this attached to your IDE or your GitHub account or your Git server account, and you can just do your changes and push your changes or commit them, and you'll see that your changes have been built and reflected. Okay, back to the presentation, and we will discuss the auto scaling of this environment. We have seen that we can scale up and down the application manually by starting more containers or terminate containers as we need. However, the power of scaling is that it could be automatic based on the load and the traffic happening to your server. So for this functionality in OpenShift cluster, you have the kubelets, which will expose some metrics like CPU utilization and memory utilization, and you have Hipster, which collect this information and make it available to the master to take the proper decisions based on the configurations and limits applied on this project. So you have to assign resource limits, and the master is smart enough to figure out how many pods and how many containers it can start or terminate based on the resource limits and the scaling configurations you have applied on your application. So currently only CPU and memory utilization are the metrics available for your running applications or for your running containers. Users can view these metrics from the web console and from the command line as well. Okay, now I have 2 running pods of this application. I will just dig into one of these and get to the metrics tab. It's loading here and it's telling me that I have this amount of memory used and I have this amount of CPU used I can customize this to be on 30 minutes, last hour, last week, whatever, and it will keep displaying how many resources and showing me the spikes in memory or CPU utilization as the time goes on. So to make this metrics tab comes, we have to configure the cluster metrics, and we will discuss this in the next slide. However, what I wanted to show you is that if for this project we don't have any resource limits. So what we see here is just a flat utilization diagram that shows you how your application is behaving in terms of memory and CPU utilization. If we have resource limits applied, this view will be different. So let me switch to another user which has access to a different project on which I have resource limits applied. I will now log in with dev1. And here I have a test PHP application, which is actually the same application but with different configurations. And for this application, I have limits applied. So what you see here is a different view. You have here a donut with how much is being used out of the limits I have assigned to this project. So this shows you actually how much resources are used against the limits you have applied on this project. Okay, let's have some fun stress testing this application. I have connected to the master node and I have logged in and switched myself to this project. I will just do this again. It's OC project test PHP. And I can monitor my performance here. This is HPA stands for horizontal baud autoscaler, and this tells me what are the target I have assigned on this autoscaler. So I have assigned a target of 10% utilization, 10% CPU utilization. So I want to keep my container utilization below 10%. Of course, in real world scenarios, you would keep this number at like 75 or 80%. However, just for demonstration purposes, I kept this number low, and it tells you what is the current utilization of all of your pods associated with this project. And we have also configured that we have minimum of 1 pod, and you can scale up to 10 pods. I can also show you the limits associated with this project. So I'll do OC get limits, and this will give me the limits name, and then I will give you OC describe limits, and this will show us what are the limits we have associated with this project. So we said that it starts with 100 millicore and it can go up to 1 core of our machine, and it starts with 6 megs of memory and can go up to 500 megs of memory. And for the container, it starts with 4 megs and it can go up to 500, and starts with 100 millicores and can go up to 1 core of our machines. So with this configuration, we will not be able to start 10 instances of our application because we don't have 10 cores. And I will monitor back the HPA, and let's keep monitoring this while we generate some load on the server. So I'll use Apache benchmark to generate some load, and let's use some big number here. So we will generate like 100,000 requests using 75% of concurrency. And I will do this also from the other machine here, so we have like big spike in traffic. And I will go to the overview here so we can see what's going on with this application. So as you see here, the utilization has started increasing. We are now at 4%. It will go up, and once we hit utilization more than our target, it will start spinning up more and more instances of this application. Okay, so we are at 16% now, and you see that it immediately started another instance of our application. And if we configure the limits correctly on our applications, and we have more resources in terms of CPU and memory for our resources, we can definitely spin up more and more instances. We can spin up to the 10 pods that we have defined as the max pods for our scaler. So currently it just started 2 because this is available based on the available resources. We are at 25% utilization so far, and I will just terminate these benchmarks so we can see what happens when the performance declines. We are still at 21%. We are at 1% now. Once we get back to 0 and stay there for a while, it will terminate the additional pod that has been started as part of this scaling process. Okay, we are at 0% now. It will just take some cooldown time to make sure that there is no more traffic is coming, and once we stay at 0% for some time, it will scale down. Okay, we stayed at 0 for some time, and you see that it scaled down to the 1 pod, which is the minimum we defined for this application. So that's it for this overview. We have explored OpenShift Enterprise and the platform as a service, and we have explored the architecture of OpenShift Enterprise and the technologies, core technologies associated with this product. And we had a couple of demos to explore the environment, the admin console, deploying an application, and we have also tested the auto-scaling functionality of this environment.